Good evening, all of you.
Good evening.
Good evening,
Good
sir.
evening, sir.
We were supposed to clear doubts of which exercise of rotational dynamics first.
Sir, in
Exercise
our
one.
batch from
Exercise
exercise
one.
1.
In any other batch, did I complete exercise 1?
Sir, in our batch,
Yes,
OPJC 1 only
OPJC
exercise
1, exercise 5 is remaining.
Okay, can we start from exercise 5 then?
Yeah, sir.
Exercise 5.
'53, '54.
4, 5.
36.
3-6 or 4-6?
36.
4.
44.
So 21.
So 8.
29.
44.
Sir, 11.
40.
38. 38.
So 37 part B, the second.
एक सेकंड रुको, एक्सरसाइज 5 खोलना पड़ेगा.
So 25.
एक सेकंड. बड़ी से 25.
So लिखा हुआ है, लिखा हुआ है.
ओके. फाइन.
Sir, 50.
So 14.
थांबा, ये होने दो. ओके. Now listen. Fourth question में you are giving me an alphabet H and you are rotating about this. So loss in potential energy should be equal to gain in kinetic energy. When it is rotating about this rod is coming down by L by 2. All the three are of the same length. The rigid body is made of 3 identical thin rods, all of the same length. So MGL by 2 plus MGL. This will come down by L. It's an alphabet H, right? You have to do this way. And there is a H like this. Now when it comes down this way, this mass came down by a distance of L. The blue marker came down by a distance of L by 2. Right? So this will be equal to half I omega square. If you can tell me I about this axis, my job is done. What will moment of inertia of this rod about this axis be? It will be ml square by 3. Moment of inertia of this rod about this axis. Every particle is at the same distance. So it will be ml square. I get omega.
Sir, can you explain the moment of inertia part?
Moment of inertia of this rod plus moment of inertia of this. This rod about one extreme end is ml square by 3. Every point of this rod is at the same distance of L. So it is ml
Yes, sir.
square.
Yes, I got.
Eighth question. This is the rod. I'll draw the rod a bit separate so that you can draw the free body diagram here. Here I always keep forgetting whether these are fixed or moving. I think I assume they are fixed. Now this rod will move downwards, mg. That means friction here will be F, friction here will be F. This will be F and this will be F. Reaction of the friction on this will be F. On this will be F. This will be F, this will be. I think this will tell you what to do. Your equation will be mg minus 4f is equal to m into a. Acceleration of this will be f into r is equal to I into alpha. I will be the moment of inertia of the disk. Second equation. And then acceleration of this point and this point should be the same. So r alpha should be equal to a. Third equation. Mass m dash of the disk is negligible. All that conditions you will get from this. Bar is negligible, make this 0. Moment of inertia of the disk is negligible, make this 0. So you know what all conditions you have to apply. These are the general equations. If he says any mass is negligible, make the mass of that 0. Tell me when I can rub the board.
Yes, sir.
Yes, sir.
Question number 11. Question number 11 में the catch is this velocity is 12 centimeters per second and this velocity is also 12 centimeters per second. Double pulley is attached to a slider block by a pin at B. 2 centimeters radius inner pulley is rigidly attached to a 4 centimeters radius outer pulley. Knowing that each of the two cords is pulled by a constant speed as shown, determine the instantaneous center of rotation of the double pulley. Now this is 2 centimeters, this is 4 centimeters. Instantaneous axis of rotation will be somewhere here, let us assume. So you will take R1 plus R2 is equal to 6 centimeters is my first equation. Second, 12 by R1 is equal to 12 by R2. This is 12, this is 12. So from this I get R1 equal to R2, I get R1 equal to R2 is equal to 3 centimeters. That means this is, B is the pin, but instantaneous axis of rotation will be at this particular point. Velocity of that point will be 0. Velocity of which point will be 0? Instantaneous axis will be 0. Not the point B. Velocity of which point will be 0? Instantaneous axis. That is what is whole of the game about instantaneous axis of rotation. Yes or no?
Yes, sir.
Now, why are you emphasizing on this? Because velocity of the slider block, velocity of the slider block, once I get omega from this, I know R1 and R2. Can I find out omega? Omega is 12 by 3, 4 radians per second. Once I get omega, velocity of this with respect to the instantaneous axis plus velocity of the instantaneous axis with respect to ground is the velocity of this point with respect to ground.
Yes.
Now, velocity of this point with respect to the instantaneous axis is 0.1 into omega. Velocity of B with respect to C plus velocity of C with respect to ground is velocity of B with respect to ground. Velocity of C with respect to ground is 0. Instantaneous axis is 0. So velocity of B with respect to C is 0.1 into omega. That will be velocity of B with respect to ground. Now when they ask you length unwrapped, find out the velocity of this. I already know the velocity of that. No. Find out the velocity of this with respect to the instantaneous axis and then solve the problem for length. Type V, this is the unwrapped. So R omega will be in time t, the R omega will be the length unwrapped. In 1 second, R omega will be the length unwrapped. Can I rub the board?
Yes, sir.
One. Stationary free rod, mass m, smooth horizontal table struck at A by a particle of same mass, moving velocity V naught, coefficient of restitution 0.5. Find x and y coordinates of the point B as a function of time t, taking the origin to be fixed at the initial position of the center of the rod. Take the initial position of the center of the rod as origin and take positive y-axis along the rod and towards A and y-axis along. Here, I think we have done quite a few similar questions of this nature. Only thing we didn't ask for the coordinates. 21. A stationary rod AB. This is A and B. Of mass m on a smooth horizontal table is struck at one end A by a particle of the same mass moving at the E, same in the same plane with a velocity v naught. Agreed? Perpendicular to the rod. Coefficient of restitution small e is 0.5. Happy about it. Find the x and y coordinates of the end B as a function of time, taking the origin to be the 2B fixed at the initial position of the center of the rod. Here, rod will move ahead and that origin will remain there. And positive y-axis along the rod and towards A and x-axis along the initial velocity of the particle. That means this is y-axis, this is x-axis. And he wants coordinates of point B at what time? As a function of time. No big deal. Have a look at it. Conservation of linear momentum. This will have clockwise omega, right? Let me take clockwise omega. Now this will be moving with velocity v. I'll call this vc. Vc. Right? Conservation of linear momentum mv naught is equal to mv plus mvc. Identical masses, so this job becomes easier. Angular momentum, you want me to conserve about which point? You tell me the choice. You have been taught the points about which you can conserve angular momentum.
Point of contact.
Point of contact in air which is at rest. Yes or no?
Yes, sir.
Sir.
So initial angular momentum is 0 plus 0 is equal to final angular momentum is 0 plus angular momentum of the rod about this point. It is angular momentum of the rod about center of mass, ml squared by 12 into omega, minus mvc into L by 2. Angular momentum of this with respect to this is anti-clockwise. M and M will go. First equation V naught is equal to V plus Vc is my first equation. Second equation ml squared by 12 into omega is equal to mi cancelled will be equal to Vc into L by 2. This will become 6, 1 L will cancel. That implies Vc is equal to omega L by 6. This is my second equation. Life actually becomes very simple with these two equations. He has given you a third equation as well. This is L by 2 omega plus Vc. 0.5 is equal to L by 2 omega plus Vc minus V upon V naught minus V. Third equation. Three equations and three variables. V, Vc and omega. All three you can calculate. Once you calculate, he is asking you the angular x coordinate and y coordinate of this as a function of time. X coordinate and y coordinate of this as a function of time. After time t, just imagine if this origin I draw here, after time t, the rod rotated like this, right? After time t, this is moving constantly with a velocity c, and this has a constant angular velocity omega, which I already calculated. Because of which I will have L by 2 omega this way. This will have a vertical and horizontal component. I will consider this to be theta. The rod rotated by an angle of theta, so this is theta. L by 2 omega sine theta. This will be L by 2 omega cos theta. Right? Now, y coordinate, you know the velocity of the point B in the y direction. You know the velocity of point B in the x direction as a function of theta. Theta will be omega t. As a function of theta, what is the value of theta omega t? I repeat, last step I will be skipping, listen carefully, just copy it out. Velocity of the point B in the horizontal direction will be Vc minus this. Velocity of the point B in the vertical direction will be this L by 2 omega sine theta. I know the velocity of the point in the vertical direction along y-axis, in the horizontal direction along x-axis. If I know the velocity into time, displacement is velocity is displacement by time. Displacement is velocity into time. Into time, I know the displacement of point B along x and y. If I know the displacement, can I calculate the coordinates?
Yes, sir.
Only thing is that when the rod is rotating this way, as it is moving up the y coordinate, I should, to get the coordinate from the origin, I have to subtract that distance. See, this is the origin. A point is moving up. I can calculate this distance moved. Y coordinate will be the balance length, right?
Yes, sir.
So once I know the velocity of this along x-axis and y-axis, displacement is velocity into time. I get that as a function of time. Now, displacement of this along x-axis, velocity is Vc minus L by 2 omega cos theta. Along y-axis, velocity is L by 2 omega sin theta.
Done, sir.
Twenty-four. Uniform disk rolls without sliding on a horizontal surface. Find the ratio of the total kinetic energy of the upper half part to the total kinetic energy of the disk. The question is a very tricky one. Observe carefully. Total kinetic energy of the disk. If I take V and omega, total kinetic energy total will be half ICM omega squared plus half m VCM squared. Or you would say about this half I omega square. About this half I omega square. Do you agree with that?
Yes.
अपर हाफ जब कैलकुलेट कर रहे हो ध्यान से देखो center of mass of the upper half will be at a disk. Center of mass 4r by
4r by 3.
now please find out the velocity of this. I will call this V, name this at some point. Once I call this P. Velocity of point P. You'll have to calculate the velocity of this because now kinetic energy will be kinetic energy of the disk about its center of mass less kinetic energy of center of mass with respect to ground. Now center of mass, let me call it as C. You will be able to correlate. So kinetic energy of this is half IC into omega square plus half m VC square. M will be the mass of the disk, mass of the upper half. Don't tell me this m. This will technically become m by 2. Right? Now, listen. Omega will be omega of the body, rigid body theorem. That will not change. I about C you have to calculate first of all. That's also a catch. VC is also a catch. There are two beautiful catches in this problem. I about C, how will I calculate? You know I about O, right? You know I about O. Call this O. I know I about O. For this particular body, it will be m by 2 r square by 2. mr square by 2. This is I about O, which will be IC plus m into 4r by 3 pi whole square. I used parallel access theorem plus m into d square.
M by 2.
Right? Now find out IC. Right? Find out IC. This IC I will substitute here. Now omega is the same. Now find out VC. How do you find out VC? You know the original velocity here. Right? Or do one thing. Life becomes much more easy. You know omega. You know velocity at the lowermost point is 0.
Yes.
Yes.
You know this whole distance. Temporarily I'll call this R. R into omega. Because you know omega you get VC. Substitute here you get the answer. It's a very catchy problem. 24th one. Generally nobody gets it in the first attempt. The reason being kinetic energy, always remember kinetic energy of the body about its center of mass plus kinetic energy of center of mass with respect to ground. If you take the upper half of the disk, please calculate about the center of mass of the upper half of the disk.
Sir, could you just re-explain the IC1 part?
Moment of inertia about the center of mass. I know I about O. Because if you take any test, I about O will be mr square by 2. Even if I take one part of it, it will be mr square by 2.
Yes, sir.
So for this semicircular test, right, I about O will be mr square by 2. But m will be m by 2 because half the disk only is taken. Will be equal to IC plus m into d square. Parallel access theorem. D is 4r by 3 pi. M by 2. Why don't we?
Got
So
it.
once you get IC, substitute here. You should get PC, your job is done. PC, generally we calculate with respect to O plus velocity of O with respect to ground. I will get velocity of C with respect to ground. Right? But instead, take it with respect to this point. This point is at rest.
Got it, sir. Done, sir.
1 second. So 25th is a very typically bad problem. This needs help. Have a look at it. You have fixed this way. I am amplifying the diagram. This is the hinge. Now what happens is, this is being pulled with a force of F. Right? Now here, because of this, I will take a normal force of N1. Because of this, I will take a normal force of N2. When I am pulling this, I will have frictional force of F1 here, frictional force of F2. Firstly, did you understand this free body diagram? Here also I will have friction F1, here also friction F2. Normal force on this surface I am taking N2. Normal force on this surface because of the upper block I am taking N1 downwards. Firstly, free body diagram. Everybody clear with that?
Yes.
Now, reaction of this on this block will be N1 in this direction. I take this distance to be X. Or I will take this distance from 3 centimeters. You are moving from here. This distance I take as X. This will be 3 centimeters, meters, something given, 3 meters. So from the center, it moved by a distance of X. Now, for this block to be in equilibrium, I will take this to be capital Mg. Capital Mg into 3 is equal to N1 into 3 plus X. See if you are convinced. For this block to be in equilibrium, about this point, clockwise torque should be equal to anti-clockwise torque. This N1 is the reaction of this. This N1 is the reaction of this. Tell me if you are convinced or not.
Yes, sir.
Yes, sir.
F1 will be mu N1, F2 will be mu N2. Agreed? Now work done here will be force minus F1 minus F2 into displacement X. should be equal to the net total work done. Right? Capital F is given. Right? Value of F1, I'll use a different thing. Value of F1 will be mu N1. Value of F2, mu N2. By the way, you know how to calculate N2. N1 plus Mg will be N2. How much will N2 be equal to? N2 is equal to small mg plus N1. This small mg plus N1. That's it. Change in kinetic energy. Calculate this work done, you will get change in kinetic energy. First equation, second equation, and third equation. Should not be difficult after this. The free body diagram is the main catch in this.
Done, sir.
So just a That's
Sir, you are making this week's TWT.
Pardon?
Are you making this week's TWT?
Am I taking this week's TWT?
Making, sir, making the question paper.
No. Now 26. If you have tried this problem sincerely, you will have a very small typical doubt that it may appear that the question is wrong. A drinking straw, thin cylinder, mass 2m, smooth table, orthogonal, extends, fly, mass lands on the inner end A of the straw and walks along the straw until it reaches the outer end B. So this is 2m. There is an insect of mass m which will move to the other side. Now you will feel the moment the insect crosses this point, the straw will topple. जिसका भी ये doubt है, that will be a doubt. You forgot the previous chapter, center of mass and conservation of momentum. This is on a smooth table. When the insect goes towards that end, this will move backwards. Small m into, if the insect moved by a distance of L with respect to the straw, what is the length of the straw within 2L or L? They didn't give, take it as L. L minus X is 2m into X. 2m moved back by X. This moved ahead by L minus X. ML is M plus 2m into X. X is equal to L by 3. That means the straw moved back by L by 3. Now I will redraw the diagram. Observe this. Straw moved back by L by 3. Now this distance is L by 3. When the insect is here, this is M, this is 2M. Now this is the new situation of the problem. Now you are asking me, how much maximum mass can land here, M dash, so that system is in equilibrium. The combined center of mass should not cross this particular point. The combined center of mass and 2m and m should not cross this point for it not to topple. अब कर पाओगे?
So, sir, how is it a rotation question?
About this point, the moment center of mass moves, it will topple. That's rotation. You are taking torque about this point. torque due to this weight and this weight should be equal and opposite or become zero at this particular time?
Yes, sir.
और अल्लाह करते वक्त सभी सेक्शंस के बच्चे दिखाई देंगे मुझे अभी क्लास में तो सिर्फ ओल्ड एपीजेसी 1 के बच्चे दिखाई दे रहे
So which of the batch is that?
हैं हाँ ओल्ड एपीजेसी 2 and 3 तीनों को लिंक भेजा है अभी जब हल्ला करते वक्त तो बहुत सारे लोग करेंगे डाउट्स लेंगे तो कुछ लोग ही आएंगे From old APJC 3, I could recognize one girl's voice in the start. I don't know her name, but she sits in the second bench, last class. She was sitting to my left. Second bench in the middle row, middle column.
Sir, which class?
To old APJC 3.
Priyal, वो
So there's a couple of people here from 3. I am also from 3.
3 people switch on your cameras. 3 के बच्चे switch on your cameras. Dev, Kar, Rushabh, okay, 3 I recognize you very well. Dhriti, yes, I recognize you. One girl in the start, I heard her voice. I can recognize her. She's from 3.
Real.
So maybe
So that
not
was
everyone
Priyal.
did exercise 5.
No, that was not 3 years back. Wait.
It may be Priyal.
So there are only 3 students from old APJC 3. बाकी लोगों को डाउट है ही नहीं.
Sir, exercise 5 नहीं किया होगा उन लोगों ने.
There is one student who typed a message. I am from old APJC 3 but unable to switch on the mic. Okay, fine. Slightly disappointing, but okay. Now, where am I? Next number 29. Ring rolls on a horizontal surface. This I dealt with in detail in the class by dealing with angular impulse. Do you people recollect this? Here you are categorically told this is mg, this is normal force, and this is frictional force. This height is h. Now initially this body is moving with a velocity u and omega. Now when it strikes here, you can conserve angular momentum only about this particular point. Why? Because this is also impulsive, this is also impulsive, while mg is non-impulsive. So students initially feel they'll conserve angular momentum about the center. Don't conserve energy directly. You cannot. It is a inelastic collision here. The body is in contact with the edge when it is climbing up. The body is in contact with the edge when it is climbing up. Right? So do not conserve angular momentum. Do not conserve energy directly. Second, You cannot conserve angular momentum about C directly because friction is a non-impulsive force. This is impulsive. This is also impulsive, while this is non-impulsive. Agreed?
Yes, sir.
Now, before the impact, angular momentum before the impact will be about this particular point. Angular momentum of the body about center of mass, ICM omega naught, plus angular momentum of center of mass, mu into r minus h. Mu into this distance, r minus h. Mu into r minus h. This is the initial angular momentum. Final angular momentum of the body about this. It is not losing contact with this point. So it is pure rotation about that point. I about omega into omega dash. Find out the new omega dash just after impact. Right? Once I know omega dash, I know the kinetic energy. Half I about O into omega dash square should be sufficient to climb the step. Center of mass should rise up by a height of mgh. This kinetic energy should be just sufficient for it to climb the step. Find out the new omega dash. Omega dash you are finding out about OR, rigid body theorem, about any point of the body will be the same. Why did you take I about O? You are conserving angular momentum about O. And now after collision, it is in contact with O. It is subjected to pure rotation about O. When something is subjected to pure rotation about O, you get I about O into omega. Half I naught into omega dash square is equal to mgh. Key catch in the problem is realizing that you can conserve angular momentum about O and not about center of mass. This is something which is important. Tell me when I can rub the board.
Yes, sir.
Uniform rod of length 2a is placed horizontally on a fixed 10 horizontal rail at right angles to the rail and is released from rest. Initially, center of the rod was at a distance of a by 3 from the rail. If the rod slips after it has turned through an angle of theta, find the coefficient of friction between the rod and the rail. Listen, rail is something like this, a table. A rod is kept this way such that he is telling you length of the rod is 2a. Horizontally on a fixed thin horizontal rail at right angles to the rail and is released from rest. Initially, center of the rod is at a distance of a by 3 from the rail. This distance is a by 3. This is what you are telling me initially. Agreed? After some time, the situation is this will turn this way and it will just start slipping. Agreed? When this makes an angle of theta, it starts slipping. So you will have a normal force this way, you will have mg this way, and you will have friction this way. You are taking friction as mu n, because it is at this point it will start slipping. If the rod slips after it has turned through an angle of theta, at this instant rod slips. If the rod just started slipping, what is the value of friction?
Limiting mu.
Limiting friction. Now, how do I incorporate the fact that the rod is rotating till now? Look at my equation. Here, rod is rotating about this particular point. This will be mg cos theta, and this will be mg sin theta. Listen carefully here. I have a feeling I must have done this in the class, but it's okay. Mu n minus mg sin theta will be equal to m omega square
Circular motion and all concepts.
a by
You have
3.
done this.
Yes, sir. You have done this in the
By
lecture.
right? Here you have incorporated everything. The fact that the rod is rotating, the fact that it is just about to slip. Rod is rotating, provides the required centripetal force. Just about to slip, where did you incorporate? The fact that friction is mu n. This is my first equation. Now, if you can substitute omega, and then your job is done. Omega, how do I substitute? Loss in potential energy, mg, this height, a by 3 sine theta will be equal to half I about 2 into omega square. I am taking this as O. This omega substitute here, 1/2 of the problem is done. To calculate n, what will you do? Mg cos theta minus n is equal to m into a. In an attempt to calculate n, I incorporated a new variable called a. How do I eliminate a? Take the torque about any point ले लो. Alpha आएगा. A will be equal to how much? This A is not this A. I have a very bad habit of using the same symbol for two things. Here A is the length. Here this A is acceleration. Use capital A. Don't mess up with it. Capital A will be equal to A by 3 into alpha. Take torque about center of mass or about it. You have two choices, either about center of mass or about it. You pretty well know why you should take the torque about center of mass or about a point which is not accelerating. Yes or no?
Yes, sir.
So,
Once I take the torque, I get alpha. Once I get alpha, substitute this n here, your job will be done. This is a very important type of a problem which generally I cover in the theory of the class. Maybe I missed in some section. Somebody asked this as a doubt. Only thing, I take the length of the rod as L. I connect a string here and tell you what is the string breaks. It starts rotating. I take this as L by 4. They have taken as A by 2. The value string, that's all.
So you could write A equal to A by 3 alpha because it is pure rotation about 4. Right?
Right. Acceleration of this point with respect to O plus acceleration of O with respect to ground.
Okay, yeah.
The acceleration of this point with respect to ground. Acceleration of this with respect to O is R alpha, E by 3 alpha. Plus acceleration of O with respect to ground is 0.
0. Done.
Now, 36 instantaneous axis of rotation.
We
Have
have
a
done
look.
this in class.
I've done this in the class. That's what I don't know why they are asking. If somebody, it's okay. क्या बहुत दिन हो गया करके. There will be one point y. This is moving with c because the omega is like this. This will be y omega. Instantaneous axis is that point which will be at rest. Right? If the initial moment, the axis c of the disk is located at the point O. With the constant velocity, first bit is constant velocity v, where the disk starts rotating counterclockwise with a constant angular acceleration beta. Now, when will this be at rest? When vc minus vc or v, what did he say? He said v minus y omega should be 0. V is equal to y omega. Y omega will be how much? Alpha into t. Here it is beta into t because he gave angular acceleration as beta. He changed the symbol. Initial angular velocity is equal to 0. What formula did I use here? Omega is omega naught plus alpha t. Omega naught is 0. Alpha is beta into t. This is my v is equal to y beta t. This is my first equation. Second equation is x is equal to v into t. X is this displacement. ऐसा कैसा लिख लिया यार v equal to t? यार आपने बताया क्वेश्चन में कि it is uniform speed. Uniform speed बोला है कि नहीं फर्स्ट बिट में? Now eliminate t from these two and v. Will I get y as a function of x? Can I?
Yes, sir.
Now for the second bit, he's telling you omega is constant and v is accelerating. ऐसा अगर v is accelerating, how will I get displacement x? Half a t square. X is half a t square in the second bit. While omega is constant. Omega I will write as and ultimately you need y as a function of x.
Yes, sir. Done.
Now 37.
So you have done that in the class, but I had it out in the B part. I forgot how you had taken.
37, I actually didn't do the B part in the class. No, listen. We dealt with the upper point. 37, A bit, what bit it is. Here you have an observer, here you have an observer. This observer will see this going with 2 times VCM. This is VCM and this is omega. So I'll remind you people for the A bit. What is the radius of this? Acceleration of this element as seen by this observer and this observer should be the same. So what we did here is acceleration of this as seen by this observer is 2 VCM minus VCM whole square by R. Acceleration of this as seen by this observer is 2 VCM whole square by X. You calculated X. This is VCM square by R is equal to 2 VCM square by X. 2 square rather 4. So X is equal to 4R. This was the first bit which I did. I didn't deal with the second bit here.
नहीं सर डाउट्स में क्या था एक बार हुआ था डाउट तो बी पार्ट भी क्या था पर आई फॉरगॉट व्हाई डिड
Okay, listen. B part mein the only mistake which you people will commit is you have one observer here. This will be R omega, this will be VCM. Right? Acceleration of this as seen by this observer is R omega. VCM is R omega. R omega whole square by R. You can write R omega as VCM because body is rolling. VCM is R omega.
यस सर
This will be √2 times VCM. Right. This is the acceleration as seen by this observer. Acceleration of this element. You agree with that?
यस
Now the man standing here on the ground will see the resultant velocity √2 times VCM. Agreed? He will see √2 times VCM.
yes.
I should take the radius along this particular direction. I'll take X. Right?
Yes.
But now I have an issue here. If I take X, I'm getting the acceleration along this direction, which I have to resolve along this direction and then equate it. This acceleration is toward the center. So this √2 VCM whole square by X. I'm getting acceleration along this direction. That into cos 45 is something that I shouldn't forget. √2 times VCM square by X, I will get acceleration in this direction.
Yes.
This acceleration and this acceleration which is towards the center, I just cannot equate it. They are vectors. I should resolve them along the
Okay.
same
Yes, sir. Got
So this acceleration I'll have to resolve in this direction and equate it to this.
yes, sir.
Finished 36, 37. Okay.
$38. We'll continue from 38 in the next doubt lecture here. I'll keep one more doubt lecture every week in the evening, 7 o'clock, 7 to 8.
Okay, sir.
It will take me 2-3 lectures, but I'll finish off in 2-3 lectures. Okay, but
Okay.
we'll go in this sequence from exercise 5, they will go to exercise 4. Exercise 4 is very small. Exercise 3 also is very small. Right, then we'll come to exercise 2 and 1. We'll follow the same sequence. 1 hour ka lagayenge and we'll finish it off. Actually,
So,
day
sir-
after tomorrow, I would have put up one more, but incidentally, I'm out of out of station day after tomorrow. I'm not in station. So next week I'll keep 2 doubt lectures in the evening.
So we can't do it
हमारा
in the
ऐसे भी
class.
बात सिर्फ अच्छे एक लेक्चर ही नहीं है नेक्स्ट वीक लेक्चर
Yeah, I'm not there in station on 2 days. Friday, Saturday, I'm not there in station. So there is a difference in the timetable. If not, we'll have 2 lectures, right? जिस दिन भी lecture है उस दिन शाम को 7 बजे we'll keep the doubt lecture and finish it off. 1 hour.
Okay, sir.
With whatever you have done till now, you'll be able to take the topic wise test. Don't worry about it.
Okay, sir. Thank you,
you
sir.
have seen the paper
I have seen the paper.
How is it?
I don't know.
ये क्या बात हुई सर? ये क्या बात हुई?
It's easy, not difficult. Major test से तो difficult नहीं होगा कभी भी. Topic wise test will always be easy.
सर इसका कुछ भरोसा नहीं.
सही अक्षर
चलो अगर difficult है तो एक और अच्छा assignment sheet मिल गया आपके लिए. Suppose assume, let's look at the positive side. Suppose if you find it to be difficult, you will again resolve it at home. एक अच्छा assignment sheet मिल गया.
हाँ सर वो बात तो है.
See, neither your parents nor we are keeping a knife on your throat and telling you इस topic wise test में इतना मार्क लाना ही है. थोड़ी बोला हो. You are able to attempt, good. You are unable to attempt, let's learn from the mistakes.
Yes sir.
There is a very wise saying. If I made 100 attempts to a problem and yet could not solve, there are 2 ways of looking at it. You may consider me to be dumb, and you can please do your. See, let me complete this. If you ever made 100 attempts to a problem, right, and then I couldn't solve it, that means there are 2 ways of looking at it. 1, you think I'm dumb. 2, look at the other side. Now I know 100 wrong ways of doing that problem. My possibility of success has increased. Yes or no?
yes
Yes sir.
Look at the positive side. Somebody says you didn't show us your library. I reverse the camera, have a look.
तो
अरे
दिखा है 2-3 बार
कितने बार?
तो 3 वालों को नहीं दिखाया था.
सर नहीं दिखाया.
तो
ये
फिर तुम
मेरा
लोग को
लाइब्रेरी है.
तो फिर तुम लोग को मालूम कैसे पड़ा कि यहाँ पे सर्कस लाइब्रेरी है?
सर ने बोला क्लास में.
अरे बाप रे.
so where are you going
Where means?
Where are you going?
घूमने
घूमने के लिए जा रहे हो सर?
Visakhapatnam, my hometown, to my parents' place.
सर हम
वाह
इधर
सर
टेस्ट
enjoy
लिखेंगे सर, आप उधर जा रहे हो सर, ये चीटिंग है.
अरे 2 दिन के लिए जा रहा हूँ.
सर इसको चाय देके चुप करो
अरे यार
Oh, I understood.
अबे
I thought you are missing
बारिश
me. You are missing the tea, is it? Okay, okay.
सर इससे पहले वड़ा पाव मांगो सर, वड़ा पाव भी नहीं दिया.
उस बंदे से पूछो ना यार जो लेट आ रहा है क्या क्लास में?
सर
तो
मैं ही
वही बोल रहा है सर कब से.
Okay, chalo. See you people in the next class.
Bye,
बाय सर
sir.
थैंक यू
Yes.
Hi, sir.
Good day.
रखने के
Bye.
पर